Good morning, all. Welcome to today's session 5 of Module 4 Sampling and Quantization. In this session, we are going to discuss about pulse position modulation, generation of pulse position modulation wave, detection of pulse position modulated wave, and MCQs, that is multiple choice questions related to today's session. So first we'll see pulse position modulation. What is this pulse position modulations? See, in this type of modulation, both the amplitude and width of the pulse are kept constant. We vary the position of each pulse with reference to a particular pulse. Here, a single pulse is transmitted with the required number of phase shifts. So this pulse position modulations can be obtained by from pulse width modulations. This first we are going to obtain pulse width modulations. Pulse width, we are going to change the width of the pulses, and then we'll change the pulse position of the pulses. So this is done by getting rid of leading edge and bodies of PWM pulses. The main advantages of pulse position modulation is that it requires constant transmitter power output, while the major disadvantages in that is it depends upon transmitter receiver synchronization. So now we'll see generation of pulse position modulated wave. So this is the block diagram of PPM wave, which consisting of a comparator. So input, we are giving input signal x of t and a sawtooth signal, are both are the input for the comparator. So the output of the comparator is PWM. Means first we will generate PWM, pulse width modulation, and then we'll pass this pulse width modulation through a monostable multivibrator. So the output of this monostable multivibrator, we will get a pulse position modulated signal. See, the pulse width modulation pulse is obtained at the comparator output applied to a monostable multivibrator. The monostable multivibrator is negative edge triggered. So hence, corresponding to each trailing edge of pulse width modulated signal, the monostable output goes high. So it remains high for a fixed time decided by its own RC component. So thus, as the trailing edge of the PWM, this pulse width modulated signals keep shifting in proportion with the modulating signals x of t. The pulse position modulation pulse also keep shifting as shown in the figure. See, these are the waveforms of pulse position modulations. See, you can see here, these are the sampled pulses. You are having input as analog signals, that is the m of t or x of t. And here you can see the last ppm, the position of the pulses are changing. See, the position is going to be changed in this case. Even here, see, the sawtooth x is the input. Sawtooth and the x of t are the input for the comparator. See, this is the sawtooth, and here it is an input x of t. These two will become the input for the comparator, and the output of the comparator will give the PWM, that is pulse width modulated output. So in this pulse width modulated output, what happens? The width of the pulses are going to be changed. See, it's keep on varying with respect to the message signal. See here, this is your message signal x of t. This is your message signal x of t, and this is going to be varied with the pulse. See, as the amplitude keep on changes, the width of the pulses are also changes. As it reaches the maximum amplitude, the width is also more. See here, you can see the width, and then it's keep on decreasing depend upon the what is that um, amplitude of the message signal. And you can see here in the end, you are having ppm. The position depend upon the pulse width modulated output. The position of the pulses are going to be changes in the pulse position modulation output. See here, width is not varying, only the positions are going to be varied. So next, detection of ppm. So first we generated and now we have to detection. This is going to be happen at the receiving side. So this is the block diagram of ppm wave, detection of ppm wave. It consisting of a pulse generator, reference pulse generator. Here rs flip flop is there and q is the output. Rs flip flop is there and q is the output. And then it is given to the PWM, that is pulse width modulation demodulator, and the output of that we will get a message signals. So ppm is the input for this. So the noise corrupted ppm waveform is received by the ppm demodulator circuit. So the pulse generator, it develops a pulsed waveform at its output of fixed durations and applies these pulses to the reset pin R of the SR flip-flops. The fixed period reference pulse is generated from the incoming PPM. Okay? And the SR flip-flop is set by the reference pulses. So due to the set and reset signals, applied to the flip-flops, we get a PWM signals at its output. So PWM signals can be demodulated using the PWM demodulations. So this is about the generations and detections of PPM, that is pulse position modulations. Now we will see some of the MCQs related to PPM. The first question, the process of using a pulse signal to represent information is called dash. A. Pulse modulation. B. Frequency modulation. C. Amplitude modulation. D. Phase modulations. Answer for this, it is A. It is pulse modulation. Second question, which of the following is not a form of pulse modulation? Options, pulse amplitude modulation, pulse width modulation, pulse position modulations, pulse frequency modulation. Answer is D, it is pulse frequency modulation. Third question, which of the following is false with respect to pulse position modulation? Options, can be transmitted in the broadband, modulates a high frequency carrier, pulse is narrow, pulse width changes in accordance with the amplitude of modulating signal. Answer for this D, pulse width changes in accordance with the amplitude of modulating signal. Next, fifth question, power consumption is low in pulse modulation. Options, true or false. Answer for this, it is A, it is true. Sixth question, which pulse modulation technique is least expensive? Pulse position modulation, pulse width modulations, pulse position modulation, pulse amplitude modulations, pulse code modulations. So answer for this is A, it is pulse amplitude modulations. So these are some of the MCQs related to today's session. And I thank chairmen, all HODs, moderators and content developers. Thank you.